Hi, welcome to projectbazaar.com. Our project title is a hyper-heuristic scheduling algorithm for cloud. Next we go for abstract. The abstract of our process is the rule-based scheduling algorithms have been widely used on many cloud computing systems because they are simple and easy to implement. However, there is plenty of room to improve the performance of these algorithms, especially by using hyper-heuristic scheduling. As such, this paper presents a novel heuristic scheduling algorithm called hyper-heuristic scheduling algorithm to find better scheduling solutions for cloud computing systems. The diversity reduction and improvement detection operators are employed by the proposed algorithms to dynamically determine which low-level heuristic is to be used to finding the better candidate solutions. To evaluate the performance of the proposed method, the study compares the proposed method with several state-of-the-art scheduling algorithms. The scheduling results show that the HHSA can significantly reduce the make span of task scheduling compared with the other scheduling algorithms. A new high-performance hyper-heuristic algorithm is proposed for scheduling on cloud computing systems to decrease the make span. Two detection operators, one for diversity reduction and one for improvement detection, are proposed for the algorithm to regulate the effectiveness to employ the low-level heuristic algorithms. The suggested algorithm can be useful to both sequence dependent and sequence independent scheduling problems. To access its performance on both a cloud simulator and a real cloud systems, the proposed algorithm and numerous other scheduling algorithms are applied in the cloud sim, and also the results show that they can significantly reduce the make span. It gives a high performance of hyper-heuristic algorithms to find better scheduling solutions. It is faster than the other heuristic algorithms. The computation cost is also low. Next we go for a flow diagram. The flow diagram starts with by submitting the jobs, that is the task. Here we can submit the n number of tasks. The tasks which are completely ordered into the queue to the cloud. Here the VM resources which are predicted as VM1 2 up to n. Here the scheduling performance which is done using the HHSA, that is the hyper-heuristic scheduling algorithm, the min algorithm, and the PSO and the particle swap optimization and the FIFO, which are used to compare the HHSA and the low-level heuristic algorithms. Finally, the performance which is evaluated by using the graph. Next we go for a demo of our process. First we have to start with home.java. This is our modified title of our process: study and implementation of cloud scheduling algorithm using hyper-heuristic approach. Next we go for a cloud environment generation. First we have to create the data centers. This I am going to create up to 5 data centers. These are the parameters of data centers, that they are data center name, number of machines, host ID, number of PEs, RAM and bandwidth. Next we have to create the broker, that is the intermediator between the user and the cloud. I am creating here 4 brokers. This is data center broker and the respective broker ID. Next we go for a virtual machine. Here we can create up to 8 virtual machines. The virtual machines which are submitted to the respective brokers. Here these are the parameters of virtual machines, that is VM ID, broker ID, milli instructions per second, RAM and bandwidth. Next we go for a job provisioning, that is the number of cloudlets. Here I am going to create a job as a 10. The jobs are submitted to the brokers. Here these are the parameters of cloudlet. Cloudlet ID, broker ID, length, file size and output size. Next we go to analyzing the time calculation. Here we have to analyze the execution time. This is the virtual machine and the ID, other parameters. Next is the cost estimation. Here the virtual machine ID, bandwidth, latency. Next we are going to show the low level heuristics, that is the SLPSO, FIFO and maxmin. Here the SLPSO, that is we have to analyze the cloudlet length and its parameters. Next we have to prioritize based on the cost. Here the jobs which are allocated to internal and external clouds. Here we can get the internal cloud allocation, external cloud allocation and the total profit. Next we have to get the total make span of the process for the PSO. These are the constraints, that are the start time, finish time and make span. Next we go for other low level heuristic, that is a FIFO. Here we can get a FIFO by getting the total execution time. Here we can get the cloudlets. Next here we have to calculate the turnaround time. Next we have to schedule the process. Here we have to predict the make span of the FIFO algorithm. Here these are the parameters: start time, finish time and make span. Here we have to calculate this make span by using the milliseconds. Next we go for a maxmin algorithm. Here we have to analyze the load, which are the low loaded and overloaded servers, like that. Next we have to analyze the prioritization detail, that is a low loaded server. Here the details which are uploaded into the database. This is the cold condition of the virtual machine. Next is the hot condition of the virtual machine. Here overloaded VMs are identified. These are the overloaded virtual machines and these are the parameters. Here we have to get the maxmin algorithm performance. The tasks which are scheduled by using the maxmin algorithm. Here we can get the make span of the maxmin algorithm. Finally we have to classify the operators, that is the improvement detection operators and the diversity detection operators. Here we have to find out the hyper heuristic algorithm, that is a virtual machine, allocated virtual machine, bandwidth, speed, cloudlet, which are the jobs are allocated to the virtual machines, that is the current load. Next we have to get the make span of the HHSA. Here we have to get the best scheduling and worst scheduling algorithms based on the two operators. Here the best scheduling algorithms, which is the HHSA, the worst algorithms which are PSO, maxmin and FIFO, like that. Here we have to categorize the algorithms, which are the best, average and worst case. Finally we have to evaluate the performance based on the existing and the proposed system, that is the hyper heuristic and this is the low level heuristic algorithm. This is the scheduling performance. This is the efficiency of scheduling, that is the existing and proposed method. Thanks for watching.